Go. Hi. Exam 3 coming up.
Why do you always get so depressed for the reviews?
Because it's exam and I gotta look at it. All right?
So just don't
And
look
I
at
gotta
it.
make it, grade it,
So don't look at it, just put 100
sit
on
here 2 hours bored, making sure no one ends up in front of firing squad.
Just put 100, just put 100 on top of
so-
every test.
That's the.
He does, and then he subtracts the points.
No.
Nice. Yes, that's exactly what I do.
See, but why would
Yeah,
why
this
would
is
you,
why.
Why would you do
All
that?
right. So, chapter 16, integration. And I will have to say 8 to 10 problems. We know that some of the stuff takes forever to compute. So I might have 8 problems, 9, 10, might not have a replacement problem depending on the time and spicy level of the exam, spice level.
About 8 questions and a replacement problem.
Definitely a possibility. Highest.
Highest possible.
Yes.
What type of percentage?
Probability.
What type of percentage?
The number one, numerical one. So now, what we have are double integrals, triple integrals, mass calculations. I mean, that's the center of mass and all that stuff. And then finally, change of variables. So these are the 4 topics you're looking into. Now they break into the smaller portions. Double integral is a rectangular region, general region, and polar region. So if I'm to put one each, 3 problems right there. Triple has rectangular, general, cylindrical, spherical. So that's already 1 each, let's say, that's 7. Mass calculations, 1 problem, change of variables, 1 problem, and that will be 9 problems. But then think about this. Mass calculation is not the integral, like a new type of integral like we had in the first 7. So it has to use one of these 7, which would reduce problems down to 8. So minimum number of problems is 8 that I can cover everything on the list. That's the minimum number of problems. If I have 10 problems, I have redundancy. Now, what type of problems are we expecting? Well, clearly you will have a vanilla problem which just says compute the integral. There is no tricks of any kind. You just go brute force up, calculate the integral, you're done. Double, triple, whatever it is, just inner, middle, outer, or inner, outer, and you're done, right? So that's why I would call that vanilla problem. You need to have one problem where you are recognizing that you need to change the integral either into polar or spherical or cylindrical. So that skill needs to be there, and you recognize that you can't integrate, something is wrong, or you see the headache down the line, or you started integrating and you ran into the brick wall. So types of problems. Number 1, the vanilla problem. So just do it. Number 2, change coordinates. Number 3, set up only. No calculations. Probably picture given. Sometimes it's text, but most of the time it's given picture, the one that we practice to death in class. Number 4, Mass calculations will ask for mass integral and one of the moment integrals. So we know that we would have to compute 4 triple integrals for 3D case, right? If you had to do the full problem, that's 12 integrals. So you don't have that kind of time on the exam. So the first, again, is what I call just do it. That problem is given double or triple, whatever, you just grind through the calculations quickly, you're done. Changing coordinates. So changing coordinates, which is rectangular to polar, or rectangular to cylindrical, rectangular to spherical. So this is 2D and this is 3D. Setup only, picture given. You might have 2 problems here, one for double, one for triple. Maybe 2 problems. Number 4, mass calculation. Number 5, change of variables. Change of vars, 16.7. Jacobian only, or transform the region. Now, every time I put the word only, that means the problem will have only that component. Or all given, so everything is given, all given, just get the integral going, right? So you plug everything in and so on. Types of problem. Number 6. State the formula for, and I put 3 dots. Spherical integral formula, cylindrical integral formula, mass calculation for 3D formula, formulas, right? So that's usually a gift problem, because if you don't know these formulas, then you can't do other problems, right, which are more points. So maybe you have a problem where you need to compute some of these. In terms of integration, I try to steer clear, right, of integration by part and trig substitution and all. Well, actually, you know the trig substitution one, right? What do you do if you see trig sub? You change into polar, right? So that's that one. But then, for the other ones as well. Do you have any favorites, anything that you would like me to add to this? Nothing to add? Do you have any questions in terms of calculating anything or setting up a problem given picture, or yes?
Can you just say the formula for spherical integral, cylindrical integral?
All of them.
Anything.
That's why I put 3 dots, because I didn't want to list all 17 concepts.
Okay.
Right? You have all of these integrals here. Every single one of those 7 has a formula to it.
Mm-hmm.
And then we calculated in class that we had 15 formulas in mass calculation,
mm-hmm.
right? So that's already 7 plus 15, 22, and then change of variables, the procedures, and so on. So you're talking like 25 formulas on the whole thing.
That's why we need a formula.
That's exactly why you don't need
it.
it.
But then we don't get the key question.
Anything else? So we start at the beginning of the class. We go exams like hour 20, hour 25 minutes, and then after that we will cover conservative vector fields and way to find the potential function, and that would be our Monday. On Tuesday, we're going to finish material, the curriculum, Green's theorem, and so on. And then make sure you bring the labs to work on, right? Because everything is due now. Final is in 6 days and 22 hours. No, 21 hours. 6 days and 21 hours from now is the final. Any other questions, concerns? Nada? Well, I'll see you later.